Hello, everyone. A very good afternoon, evening, or morning, depending on where you are joining us from. I'm Titash Roy, Industry Manager, Geospatial World, and I welcome you all to this special webinar today on enabling resilient infrastructure through data and intelligence. Through this webinar, we will be exploring how planning intelligence can be translated into action, how real-time data supports adaptive infrastructure systems, and how cross-sector collaborations enable scalable, resilient outcomes across urban transport and utility infrastructure. We have two very exciting panel discussions lined up today. But before we jump into those, I would take a few minutes to explore what is the current AEC global market outlook is like and what are the opportunities that are there for the digital transformation in this sector. So if we look at the global AEC market size, from 2025 to 2030, so in 2025, it's projected to, it is grow from 13.5 trillion in 2025 to approximately US $17.2 trillion by 2030, which represents a moderate but quite steady CAGR of around 5%. So this growth is primarily driven by rapid urbanization and population growth, particularly in Asia and emerging economies, large-scale infrastructure investments by governments, especially in transport, energy, and urban infrastructure, increasing emphasis on sustainable and resilient infrastructure development, as well as expansion of smart city initiatives and climate-resilient infrastructure planning. So while the overall construction market grows steadily, the technology layers within AEC are expanding much faster. So if you look at the global geospatial market in AEC sector, projected from 2025 to 2030, the numbers are expected to grow from $148.5 billion US dollars in 2025 to nearly $270 billion by 2030, with a steady growth of 12.6%. This faster growth reflects the increasing role of spatial intelligence in infrastructure planning and management. Key drivers which is favorable towards this growth of global geospatial market in AEC sector. One is the growing use of GIS and spatial analytics for infrastructure planning, site selection, etc. Integration of satellite imagery, remote sensing, LiDAR, and reality capture technologies in engineering workflows. Adoption of digital twins and spatial data platforms for infrastructure monitoring and asset management. Increasing demand for data-driven decision-making across infrastructure lifecycle stages. So geospatial technologies, as we see, they are therefore becoming a foundational layer for infrastructure intelligence. Now, moving on to the BIM market. So it is projected to grow from 15 billion USD dollars in 2025 to over 25 billion by 2030, which reflects a very steady growth of around 11%. And the growth of BIM in this sector, it is driven generally by the government mandates for BIM adoption infrastructure and construction projects, increasing demand for collaborative digital design environments, integration of BIM and digital twins, IoT and asset management systems, and also the need for improved project efficiency, cost control, and lifecycle management, which we will be discussing shortly in our couple of sessions. BIM is also increasingly moving beyond design to support construction management, operations, and infrastructure lifecycle optimization. And I hope we can discuss more on these things, in our upcoming two panel discussions. So, with this, I would quickly like to move into our first panel. So, the first panel will be on the topic data and intelligence in infrastructure planning, and I would like to introduce the three panelists for this session one by one. First of all, we would like to invite Chris Jackson. He is the European Business Development Lead AEC for ESRI. Hi, Chris.
Hi, Titus. Nice to see you.
Nice to see you too. Our next speaker is Julian Hofer. He's in Urban Data Analytics State Office for Geoinformation and Surveying, Germany. Hello, hi, Julian.
Hi, Titus. Nice to see you.
Nice to see you too. And our third speaker for this panel discussion is Katie Kapanadze, founder and CEO, Biminify, Georgia. Hi, Katie.
Hello. Nice to see you too.
Hello.
Thank you for inviting us.
Nice to see all of you, and welcome to this first panel discussion of this webinar. First of all, before we get into the questions, one question that I would like to ask each one of you. we can start with Chris, and then we can move on to Julian and then Katie. So across the infrastructure sector, we know that data is slowly and gradually becoming a central driver for our planning, design, and investment decisions. So, from your perspective, how is this increasing availability of data and analytics reshaping the way infrastructure projects are planned and also delivered to ensure long-term resilience and sustainability? Chris, if you can, give your perspective on this.
Great, thank you, Titus, and thanks for the opportunity to join this small discussion. I think the thing that we see about how data is reshaping infrastructure projects, well, the first thing is that everyone's well aware of the knowledge hierarchy. We need data to create information, and from that we gain knowledge, and that enables us to make intelligent decisions. So in that sense, the need for data hasn't changed. But what has changed dramatically and significantly is the volume and the variety and the velocity of the data that we can now access for planning and execution. So your report, along with a few other reports that I've seen recently, are all pointing to the fact that CXOs are turning to technology and new technology adoption to help them to make sense of this massive increase in the amount of data. So I think those things that's really what is reshaping project planning and delivery, is the increased use of technology, but also the speed at which business insight can be derived and then used to help with the process. Because when we talk about resilient communities or resilient infrastructure and the drive towards sustainable development, the thing that we're running out of is time. We've got enough technology, we've got enough data, we've got enough brain power to solve these problems, but the thing that we lack is time to do it first time right, or to at least accelerate the process of delivery. So I think that's what that's why data will continue to be a core component of infrastructure delivery, but it's the technology that's being applied which is reshaping the way that projects are being done.
Right. Thank you, Chris, for your opening remarks. Julian?
Yes, yeah, Chris, I can fully agree on that. And in our public sector, in the city of Hamburg, I would say, so in my department, I see that the process of decision making is now changing more for using new advanced tools, AI-based tools for accelerating this process. Because in the time before that, this new technology, we did have the brain power, but as you said, the time, we have this vast amount of data, and you don't have the time to get all of it and make, or at least make maybe the right decisions. So yeah, I can agree full on your statement. So.
Right. Thank you. Katie, your take on this?
Yeah, I agree, both of you, and I don't know what to add. And time is, of course, so important. But I would like to add the information as well, because the fragmented information and unstructured data has a big impact also. And to take the end product in a good case, we have to take care of the case at the beginning, and we have to take care the information as it's our own family member and so on.
Right. Thank you for your opening remarks. So yeah, Chris, I'll quickly come to you. So I was asking about geospatial intelligence. We see that it is increasingly becoming the backbone of infrastructure planning, and in fact, the market sizes that I was just presenting, it also kind of validates those points. So how do you think these organizations are leveraging spatial analytics today, especially when it comes to optimizing network planning, site selection, and infrastructure investment strategies?
Yeah, so I think the important point on this whole topic is that the leading organizations are the ones that are already talking up the value of spatial analytics and the benefits, to their boardrooms. So we talk about geospatial intelligence and it leading to business outcomes. But I think there's still a lot of work that's being done, and the leading organizations are showing this, of positioning geospatial intelligence as a core organizational competency, alongside other business systems. So when it comes to activities like network planning or site selection and so on, these organizations, first of all, have already got the backing of the board to work in this way because they've positioned it as being fundamental to their work. And what that allows is for them to then lean into these new technologies, such as the ones you mentioned earlier and that Julian mentioned, AI, robotics, reality capture, and so on. And that in turn enables them to accelerate their work and transform all of their older workflows. So I think that's the key point here. Regardless of the individual tasks, I've started to call it geospatial value creation, because it's so important for anyone that's a GIS professional to be able to get funding to do the innovation and to start to adopt the technology. And you can't do that unless you've proven the value to the boardroom. So I think that's the most important thing. That's how the leading organizations are doing it, is by making that connection to the boardroom to position geospatial as being a fundamental driver for growth.
Right. Just a quick follow-up question to what you said, Chris. So, if you can take a minute, but can you share how Esri is basically adapting to these to these new demands that are there, especially when it comes to geospatial intelligence and planning?
Sure. Well, look, our role is to serve our customers. We're a technology company. We're not the AEC experts in that sense. Our role is to serve our customers and help them to achieve the business outcomes that they're looking for. So what we're doing is aligning, certainly in the AEC industries, around what does successful project delivery look like, and two things start to emerge. The first is around collaboration, because we know that between engineering teams and GIS teams and other project delivery teams, there's a need to collaborate more efficiently and more effectively. That's what customers tell us. That's not our observation. Customers are looking for ways to collaborate more effectively. And the second is around data integration. And Katie mentioned this earlier on. It's about making sure that we can efficiently exchange data in an efficient way that enables us to accelerate and enables us to use faster processing tasks using AI to get to the answer faster. So between collaboration and integration, I think these are the two things there that, interestingly, I suppose, GIS is naturally positioned to help, because every piece of information about an infrastructure project can be positioned in time and space, and therefore the GIS and the geospatial platforms can provide that unifying framework, coordinate systems, I guess, at the end of it, as the means to accelerate both the integration, but also then the collaboration. So we're working with customers to understand those workflows and those processes to make sure that our platform is capable of evolving to meet those changing demands. And of course, we're investing heavily in AI and digital, to all the reality capture and so on. You'll see that across the platform. Yeah.
Right. Thank you. Thank you, Chris. I'll quickly come to Julian. In fact, Chris was talking about this, that there's a lot of vast amount of urban and geospatial data that we are creating. So when it comes to this, how are government agencies in Europe, particularly you or your organization, how you are building this integrated data ecosystems that also support smarter infrastructure planning and urban development?
Yeah, I mean, first of all, we need the data, and therefore we have our urban data platform in Hamburg. But I think across Europe, every big city has a urban data platform in some kind of, and especially in Hamburg, we are in a very good position because we have, for example, our department, our urban data analytics department, where we are working on projects, and especially I am working on projects with natural language processing. So, for example, we have a vast amount of data for with participation. So, in Hamburg, we for every bidding process by law, there has to be a participation process before building something, right?
Right.
And therefore, we have a digital system to collect this participation data, and this is very, very a lot of text data, and we have just developed a system that supports the experts for this participation data, the urban planners, um, for example, to get out the key messages of this participation data, yeah, and to cluster it and get some kind of, okay, this is, for example, talking about more green areas or more um, social areas like kindergartens and schools and so on. And we can map this information with our other information in the urban data platform. For example, let's look, okay, the people are talking about more green areas, but is there, I don't know, in a buffer from 700 meters, is there a green area or not? And can we build something like that, for example? Or on the other side, we are analyzing mobility data a lot. Yeah.
Yeah.
And also therefore to see where we can build maybe new bicycle roads, for example. Yeah.
Right.
And another example is in Hamburg we have this it's I think now this year by law to think about solar panels on your roof. Yeah,
Yeah.
if you have a public building, and we are now analyzing where are areas to put solar panels on, just on the LiDAR data and the satellite data, and so with computer visions.
Right.
Or just to
Yeah.
another thing is just to map, for example, the satellite data and our own data or the data in our data platform, to see if, for example, sometimes there are gaps, and we want to minimize these gaps.
Yeah.
So we are working with computer vision, for example, to find sport areas. Yeah, because sometimes there are gaps, and this is just one mini project, but just to see like a proof of concept to see if we can work on that. Yeah. So yeah.
Got it. Thank you, Julian. Just another quick follow up. Since you mentioned about different types of data, you mentioned about mobility data, satellite data. So I believe, and also correct me if I'm wrong, the form the source of these data are different. So in that
Yes.
way, are you facing any kind of challenges related to interoperability of this data, or and if yes, then how are you kind of addressing those issues?
Yeah, I mean, we try to provide the data in a standardized way. Yeah, so that's one side. On the other side, we don't want to push any data provider to say, okay, here's the structure, please use this. So actually, we try to map this a little bit, and also we
Mhm.
try to automate this process. So we have a department for that, which is looking at the incoming data and the structure of the incoming data, and to see if we can interoperate it in our systems and use it. And sometimes we have to transform the data so that
Right.
we can use it, or we are talking with the data providers. But this is more yeah, I would say not the standard way. The standard way is more our department is looking at the data structure, and yeah, we try to come up with an automated transform process.
Right, right. Thank you, Julian. I'll move to Katie now. Katie, infrastructure projects, especially bigger infrastructure projects or building projects, we see often, involves more than one stakeholder. There are multiple stakeholders, there,
Yeah.
and because of this, there might be a disconnected data systems. So, how do you think, integrated digital environments help bring together design, engineering, and operational data to, in a way, improve the planning and decision making of these projects?
Yes, you're right. Especially in the infrastructure projects, we have different kind of teams, right? We have an architect, engineers, contractors, main contractors, owner side, and so on and so on. And typically, they're working in their mind. They're using different platforms. Maybe sometimes architects are using Revit. Maybe engineers using some kind of other programs. And I'm not saying that it's not bad way. Everyone can work in their programs, whatever they like. So to become end products, successful, I think there is implementation strategy. You have to implement BIM at the beginning, whether
Right.
it's the project and whether it's the in-house. And by implementation, I don't mean that they sending their files through email and like the naming them like iSphere, its final version, and so on and so on. They have to create the system using CD, the common data environment, where everything will be shared, controlled, and owners would have their own space and like control everything they want. Of course, they need different kind of teams, and especially BIM team. BIM and digital twin is very connected, which is each other, especially in infrastructure project. And I would underline that besides the data models and just the model, they have to structure the data because it's so important. Because without this kind of connections in smart cities, you do not have smart city, right? When you have your data locked in PDFs, you have like hopeful city, not a smart city. So you have the data should be so smart and intelligent, and not just in these some kind of different layers. I think so.
Right. Thank you, Katie. Since you mentioned, about the emergence of digital twins and these kind of technologies, I'll just quickly move on to my second question for you.
Yeah.
And this is basically what I would like to understand, that with the emergence of BIM, advanced BIM, digital twins, and also integrated data platforms, how do you think that infrastructure planners, they can leverage these technologies to create a more unified and intelligent view of the infrastructure assets that they're creating?
Yeah, digital twin is really advanced BIM, let's say so. And when we are diving in a deep space, we are talking about the digital twin on the construction and the maintenance side, right? Because the digital twin is much more important when we are talking about the facility management and the buildings maintenance part. And not only in this, we are delivering scan-to-BIM processes in Georgia and not in Georgia as well. And for nowadays life, we have very strict regulations about the buildings, and also there is a war almost everywhere, unfortunately, and the buildings are destroying. So before destroying, we had one case where we scanned the whole building because they thought that it would be destroyed in the future, and they stored the data in some kind of CDs. And if something happens in future, we will be able to renovate it much more easily. And it will be very helpful when if we connect digital twin with scan-to-BIM process and in the whole BIM process as well. So yeah, I think this understanding this matter should start from the beginning. It's so important.
Right. And quickly jump, since you were talking about BIM data, how important is standards for BIM? The IFCs. If you
Yeah,
can give
perfect.
us a little bit of
Yeah.
of your perspective on that, because I know that you have been actively part of some of the Building Smart initiatives. I was
Yes.
just going through a few of those things that you posted. So I'm a bit curious about how standards are important, and what is your take on that, the IFCs and all. Yeah.
Yes, standard is so important, because we are talking about talking on a same language, right? We are working on Building Smart Georgia chapter, and I hope it will be published so soon. We want to implement it in the whole country, which is the must, I would say. IFC is so important, and open standards and interoperability is the key, because imagine
Right.
you are working in one software like 30 years, and someone is going to you and force you to change the software. I think it's so annoying, irritating, and stuff like that. And if you are working in a native environment wherever you like, I think your productivity is much pleasant, easier, productive, and so on. So OpenBeam is so important, even in just not in the buildings and infrastructure sector as well, because BIM is not just for buildings and tiny houses. We are talking about the whole life cycle.
Right. Thank you. Thank you, Katie, for sharing your perspective. Chris, I'll come to you next again. And I think this is something that we discussed earlier as well, and in a bit, that there is a long-standing challenge that is there in this sector, which is basically the disconnect between geospatial data and also the traditional engineering workflows. So, how do you see this gap, is being addressed by organizations, and what role do you think integrated geospatial platforms play in enabling more informed and planning decisions?
No, it's a great question, Titus, because we do see this difference in the mindsets, and Ketty mentioned it already, of
Exactly.
architects work in a particular way and engineers think in a particular way. So we do have this challenge of understanding things in the same way, in the speed that we need to. I mean, first of all, we see the gap narrowing, between you're right that there's still a gap between geospatial content and engineering content and so on, but we see it narrowing the whole time, because I think more and more there's an acceptance by the infrastructure community that these structures, well, they're all in the real world, aren't they? So geography and having a means to actually understand where the building is and how it performs and what the consequence of the design is, I think there is a growing acceptance that geography and maps and geospatial content is helpful, and that it should lead to a more informed design. So I think the role of geospatial platforms in that context is they should really emerge as the place to set the standards or manage the standards around coordinate systems, of geospatial referencing, of managing all of this content, which, despite whether it might be a digital twin of the building, or the digital twin of the network, or the digital twin of the of the landscape, it's all connected through geography, and it makes sense that there's one system which is sort of in the integration platform for that data. Of course, you can manage coordinate systems within other platforms. Of course, you can,
Right.
but it's inconsistent. It's still a very complicated task to create a digital version of the real world. It's a complex thing. So I think the role of geospatial platforms is to provide that integration layer, or at least the means to overlay and intersect data from different systems using that location as the common key. So you might have the digital twin of the building, you might have the BIM model as the living twin of the building, but your billings and services data will be in a scheduling system or an ERP system. So what we think of, instead of we use the word connected data environments a lot, meaning that the data should reside in its natural system of rest, and the job then is to be able to make the integration that much easier. So I think that's part of the challenge. The other thing, I suppose, we still hear GIS professionals that are frustrated with CAD plans or BIM models where it's at 0, 0. You know, there's not been any real world coordinate activity at the beginning in order to make sure that the models and the drawings are easier to connect further down the process. So I think in education, we as a geospatial industry, we've still got some work to do, I think, to help engineering undergraduates, even architecture undergraduates, just to help them to understand the role of GIS in their work.
Right.
Most engineering courses, civil engineering courses, include survey, they include geomatics, but they don't often include GIS and geospatial thinking or analysis. So I think as an industry, it's one of the things that I'm always so excited to come to the Geospatial World Forum is to try and move us along in terms of raising the visibility and awareness around geospatial as a technology that helps to transform these workflows between industries and between disciplines. You know?
Disciplines, exactly. So capacity building is basically something that this community needs to keep as a top priority when it comes to investing more on these systems.
Yeah, again, the faster we can get to a sustainable design that's going to work in the real world, the better chance we have of delivering the infrastructure that we need, you know, and that requires this understanding of the real world, which is the foundation of geography.
True. Thank you, Chris. Moving to Julian. So this is something. So basically, this is something. I would rather come to the sustainability and the resilience angle of it. So we know that in evolving urban environments, especially urban cities, and we know there are a lot of rapid urbanization that is happening. So obviously, there is a huge infrastructure demand. But however, there is also a need for environmental sustainability and quality of life. So how do you think advanced urban data analytics is helping governments and government sectors to make more informed decisions when it comes to this addressing this dichotomy that you also need to build, but you also need to build in a way that is environmentally sustainable. So Julian, your on that.
Yeah, I mean, yeah, I would say so. In my point of view, and Chris mentioned it a little bit. It's so what I'm working on is just these supporting machines. Yeah, for example, we see that in the city you have the urban planners, but sometimes you have some other stakeholders, and they are not always GIS experts, or they don't have a geospatial background, right? And on the other side, we have a lot of data in our urban data platform, yeah, for just addressing these questions for sustainability or for better social life, yeah, or for more quality of life. And then you have this gap, and we try to use now these new technologies. Yes, as I said, AI, and we try to use, for example, a chatbot which can do some kind of geospatial operations. Yeah, so you can, for example, say, okay, maybe you have like a question in your head, like, okay, how many paper containers are at a very special route, for example, like on the, I don't know, last time somebody asked me on the public transport route, yeah, in Hamburg, for example, and this question you can ask our chatbot. He's gathering the data from the urban data platform, is collecting everything and doing the geo operations on it, and is talking with the person and said, okay, yeah, for example, it's 330 paper containers on this route, yes, and then you can work with that. Yeah, also you get all the data sets that you have used, And I mean, this is one step further to just supporting. So in my opinion, it's more supporting the people to answer their questions for making solutions.
Right. Thank you, Julian. And since you mentioned artificial intelligence, and and obviously artificial intelligence right now is in a way is creating a lot of buzz. So especially when it comes to infrastructure planning as well. So how do you see AI helping infrastructure stakeholders? Which are moving from a more of a reactive planning to more of predictive and proactive decision making. You definitely gave one example, but if you can share some more examples of how AI and predictive analytics can kind of make this infrastructure planning more smarter.
Yeah, okay. As I said, I would say the decisions are more evident based, right? So on the data, and I would say it's more easier to get
Mhm.
to this decision. And yeah, for example, for I have to think what if we have another example that I can share with you.
Sure.
So yeah, I mean, as I said, for the participation data, we have this system. Yes, we are working right now on this chatbot to get your questions. We are also working right now on a system where or to integrate it in more GIS applications. Like we have this, I don't know. So in Hamburg we have this master portal. It's just a web-based GIS application, and it's open source, so every city can use it. So our philosophy is always to develop a system and to provide it to the public. Yeah, so other cities can use it. So especially in Germany, but actually in Europe, everybody can use it. So,
Right.
so that's our philosophy, and yeah, we are working uh, also to integrate this AI supporting systems in this application, for example,
Hmm.
because we see that sometimes because it's the public sector, and yeah, I mean, then now I have to dig more into the German language, and but I can but I can say it's like you have this common language, and then you have this public sector language. Yeah, and in German it's very I won't say complicated, but it's different from the common language.
Yeah.
And so sometimes to formula or to just to find a data set is complicated because
Yeah.
of the words you have to choose to find it, right?
Got
And
it.
just to close this gap, we can use AI and this new technology because there is a lot of potential. I can see this right now because I mean, for example, my favorite example in German is I'm looking for example, here in Hamburg for gyms. Yeah, because I'm a basketball player and I have a team and I want to play basketball in the gym.
Mhm.
And if you have to look in the data sets, it's not the word gym you have to look for because in German it's more like yeah, it's like a sports hall.
Okay.
Yeah, to add a little bit in English. So
Right.
yeah, you would know that if you are working in the public sector and especially in Hamburg in the public sector, but it's not always the case. So and there I think there's yeah, the
Right.
potential.
Katie, I'll quickly come to you. The topic kind of remains the same. What I would like to understand from you is how AI and predictive analytics, coming from a BIM world, what does it mean for BIM, and how infrastructure planning is actually getting affected positively with the
Sorry.
improvement of AI and predictive analytics. If you have some
Yeah.
negative, you can share that as well. But yeah.
I would not call it negative because when something new comes to the humanity, so at the first point we are so feared. We don't like changes, but change is everywhere, and we have to integrate with them. What about AI in BIM? It's becoming more and more important because we have to take responsibility to check the data as well. Without unstructured data, AI is not useful. We have several kind of plugins which you can install on your software, and it is helping you to get the result. For example, there is so important part which is called the text to BIM. You are like the negotiating with the AI agent, and it helps you a lot. Even in the scan to BIM, they're coming on the market. They're coming scanners in which AI is built on. And when you're using them, it's so important to know how to work with them. Especially in digital, when you're doing the digital twin, Internet of Things is so important, and the AI integration is really important too, and it's getting affected, of course, and we have to take care of this as well. And in BIM, I'm not sure if you have heard about it, but in upcoming months there will be new ISOs on the market, and some names, for example, BEP, BIM Execution Plan, will be renamed. As I know, it's not official yet, but LinkedIn is so full of this information, and let's wait, especially in the open standards and as well. So if we want to take here, for example, as Julian said, that there is a language barrier, right? In open standards, we have some kind of protocols, and AI is really helpful in that. We have to IFC translators, for example. We easily can translate the project, and for example, if I am a good architect and I don't speak German, it should not be a problem for me. So besides the IFC standards and IFC translations, AI is getting so deep in BIM as well.
Right. Thank you. Thank you, Katie. I think we are kind of running out of time, but I'll quickly come to Chris as well on this topic, and how you think is AI and predictive analytics, especially coming from a GIS and spatial analytics platform, how AI is kind of helping this sector, or rather these solutions or platforms.
Yeah, so it's to me, it's the AI is the next natural evolution of the power of computing to help us to solve these problems, So it's a means of accelerating the outcomes, as I mentioned earlier on. Everybody's invested, all major technology providers are investing in AI as the next means of accessing the technology. Okay, so we take the same approach. So we have two broad categories of this. On the one hand, you have what we are calling geo AI, which is about providing models and methods to accelerate the everything to do with geospatial data, whether it's feature extraction, so to fine Julian all of the roofs of a certain pitch with a certain size that could be used for photovoltaic panels, or whether it's text SAM to do agent-to-agent modeling to say, okay, well, I know that there's a natural language model over there that will understand that a sports hall is a sort of a gym, so I'll provide that to the geospatial agent, and then that can form part of the search criteria. On the buildings that might be within a proximity to Julian's team. So we're investing a lot. If you go onto we have part of our platform is called the Living Atlas of the World, which is this huge, it's petabytes of content that our users can access for their work. And within that framework of the Living Atlas, there's now over 100 different pre-trained models that our customers can take and adjust to their own parameters in order to do all of those things like feature extraction or data searching or whatever it might be. So that's on the geo AI side. And then on the other side, we have this, I've mentioned it already, but the agentic side, the stuff around the assistants. And this is, again, in two or three different ways. The first is to help users to accelerate their own work. So that's instead of taking a long time to either prepare the data or to create meaningful information from it, it's just having that natural language conversation with the tool. So create me a map of this to show that and the other. So we're developing that. Some of those are already available within the platform. And then the other part of the agent is this idea of agent to agent modeling and being able to wrap up the geospatial capabilities into a service that then can be plugged into a wider question or a bigger process.
Right.
So it's changing the way that we think about how people will access the technology. But our philosophy on it is that this is just the next change in the way that people can benefit from the use of taking this geographic approach to problem solving. So it's a natural thing for us to move into this space.
Right. Thank you, Chris, for summing this up really beautifully. And I believe with this we have reached the end of time for this panel discussion. I wish I could actually talk more with you, but thankfully I'll be meeting you all very soon at GWF, Geospatial World Forum. So I definitely would love to keep this conversation flowing during those couple of days that we stay together at Amsterdam. So thank you, Chris, thank you, Julian, and I don't see Katie in the screen, but thank you, Katie, for joining us for this for this panel. And I also thank all the audience members as well who have joined us for this webinar. And I would like to tell you that we are moving on to our next panel discussion topic very quickly. So it is on from insights to action, building resilient and adaptive infrastructure. And my colleague Ankur Vyas, he is the industry manager for infrastructure and AEC at Geospatial World. He will be moderating this next session. So thank you all, and over to you, Ankur.
Hello, everyone. Thank you, Titas. It was a wonderful session. Now, this second session, the session on From Insights to Action, will be deep diving into some of the topics that were discussed in the previous session. The topics ranging from disconnected data to multiple sources of data to predictive analytics, digital twins, and AI. And for this discussion, I would like to invite the panelists for this session. The first panelist that I would like to invite is Omar Habib, CTO, V Group, United Kingdom. The next speaker that I would like to invite is Myla Cueva, leader of Digital Twin, GeoHub, University of Twente, the Netherlands. And our final panelist would be Jeroen Zaneen, founder and CEO, AI Infra Solutions, the Netherlands. I welcome you all.
Hello.
Thank you very much.
Thank you for having us.
Great to see you all. So I would like to start with a very pertinent question that was asked by my colleague Titas in the last session that talked about interoperability. So as infrastructure systems are becoming more connected, how important is interoperability between platforms such as BIM, geospatial systems, and AI in enabling more resilient infrastructure ecosystem? And I would like to ask Myla to start with her opinion.
Yeah, thank you very much. Yes, my name is Mila Koeva from University of Twente. And before starting, just to say that I need to leave in soonish because of another meeting. So I'm happy to share my opinion on your first questions. So in our experience, digital twins are very good for data sharing, especially in these decision infrastructure solutions that we have to provide for our decision makers to take some fair decisions on how to distribute, how to tackle challenges in relation to urban climates and so on. And interoperability is one of the most critical topic. So how to develop systems that are flexible and interoperable from one case study to another case study. That is one of the most critical question nowadays, because we have been developing in our digital twin, they have many solutions that are very targeted, oriented to, for example, only water or only transport, on only urban heat type of domain, but not always the same development can be, let's say, scaled on transfer to another case study easily. Our aim as a research university is always to develop some kind of open solutions, based on open standards, based on open platforms, so that we ensure this interoperability. So, but this is a very serious challenge, because, as you know, cities are changing, needs are changing, climate is changing. So we have to be always adapting to these new systems and these new digital twin platforms that we are developing, to be tackling all these continuous changes in the urban environment. So there is no simple answer on your questions that you asked, but I would say that it's one of the most important questions that we are all the time asking ourselves when we are developing new solutions, digital twin-based solutions.
Thank you, Mahela.
Yeah.
Jerome, if you would like to go next.
Yeah, so I think like Mahela says, it's really important that it starts all with, I think, having a shared vision on what you can do. Let's say if you are a city, what can you do with the data? How do you structure it, right? Structured data, connecting open data sets that are available, nationwide data sets, local data sets. I think it starts all with structure, right? And then what I miss a lot of times is what is the definition of success, or what is the definition of done when you're working on something, right? If it's interoperability, it's really high end on connecting data sets and go from sensor to servers. What I see a lot in this industry is that a lot is we start thinking from sensors a lot of times. So I have data, or I have data come out of a sensor, and then we work towards the service that is needed, or the use case. And I think if we would all take the use cases more as a starting point, and then define, okay, when, let's say, what do we need exactly, and when is, and because we tend to go to the 100%, and sometimes 80% is already enough. So if you have those definitions in place, then interoperability becomes more easy as well. And I think there's a lot of data that can be used for multiple other use cases without knowing. Data is there, but the structures are not always there. And the vision on interoperability is also not always there. So I think that's what I miss a lot in the industry.
Correct. First, we define the outcomes, backtracking from there, and then seeing how the system works.
Well, basically, take the professional as a starting point. He or she who is working on the public space. Okay, what asset is that person working on, and what is the information need, and where can I get that information? Right? Is it already available? Is it already there? And if it's available, how do I, let's say, can get it connected with my environment, my workflow? But take the professional and the workflow as a starting point, and then also deliver as much proof behind what you deliver as well. So it's not only data, it's about analytics, but how do I prove that my analytics are right, and deliver more proof?
Correct. Omar, your opinion on this?
Yeah, just a quick one. I actually agree with Jiren with what just you mentioned, and I would say that we should kind of agree on that the ultimate goal of data construction, the absolute goal, is get data connected, isn't it? So I think if we did this right, that will make our life easier. But I would say, like in infrastructure resilience, doesn't come from model or digital twin model alone, or doesn't come from data alone. It come from decision powered by connected data. So what we're discussing here is my experience in infrastructure complex project we are working on. The problem is right in the lack of insights. You might have the data, but it's not connected enough to allow you to take decisions, and it's always kind of separated information everywhere. If I give an example, if you talk about the integration between digital twin models or with 4D, for example, so you could say the construction simulation, you could connect the time schedule with the 3D model, so you know when and how this model will be built, but you leave the context of the safety, you leave the context of the risk. So you could see the look ahead plan is you should do 1, 2, 3, but 3, 4 major activities, but end up with doing one because there is a lot of things have been the context of the information already has been missed. So what we're trying to discuss now is just integrating the information. I think we should start with end of mind. What actually we need to deliver, and actually the aim of this connected data we want to talk. I like the word that Jiren just mentioned, the definition of done, the dot. So when we're discussing, I would like to integrate, this is the ultimate kind of result we want to achieve or reach, but we need to think and start with in mind what you would like to integrate and what is the KPI you'd like to address, and then you look at the definition of done, how we make sure this has been done in the right way to address the right information or the right KPIs that be addressed by the stakeholder themselves. I give a small example with the 4D and the BIM model in the digital delivery environment. You could integrate unlimited information and use spatial information even, but even the stakeholder or the end user won't be interested in it. So if you're not defining the start with end of mind, what you actually want to deliver, and what actually how to define this, how it been done, and how to be delivered, and which kind of interest the stakeholder in, and how we're gonna receive the information also.
Umar, but the amount of data that is available today with the infrastructure operators, it's huge. So how can organizations convert this data into actionable insights to improve their infrastructure performance?
Ask me who
should start?
No.
Who are you asking?
It's for Omar.
Yeah. Okay. So I will continue saying that the context here is the data, the result itself. What what is to turn information to action? You need to know who's the end user going to use it. For example, if you are sending for executive, you need to know less information, less detail than the project director and project manager. But I would give a context of, if you're talking about one of the most effective approach when you talk about integrating the sensors with digital twin and maybe project controls information. So when you have a good understanding of the stakeholders who is going to take this information, you're going to start with define the KPIs and understand what exactly they need to be delivered through these KPIs. And what I would say, if I don't want to be very generic, actually I might give an example. If you talk again about a context of executive, he operating 3 big infrastructure project. He won't be really interested to know every single activity happening on site, how this integrated together, how everything happening there. He will need to know the earned value, what is the total progress for this, what is the information, what is the true blocks, what is the look ahead for the upcoming 2 weeks in this project. So to make it efficient, you need to understand the project, the end result, and the stakeholders getting this, and understand the position. And also try to make sure that we have a frequent data source, and we have a frequent update for different tiers. If you have tier 1, the executive, T2 is the project director, tier 3 is the guys on site, which is the operators or the project, let's say project manager. So every tier would be interested in less details than the others. So the project manager will interest in more details. So you need to make sure that your report or your information is very detailed to the limit that you understand. I would give an example. You won't give the detailed activities delayed on construction project for executive. You won't be interested in this. So I would say understand the stakeholder, and this will be very, very, very good in this side. And then when we took an example of integrating BIM with project control information, you will find that you need to have a structured database that allows you to report the different side of the projects from procurement, technical engineers, and even to talk about the BIM site with the project control information that will enable the infrastructure team to detect any kind of early issue, to prioritize the roadblocks earlier, to address it earlier. And actually, what we use typically in our infrastructure project, last banner system, we have a boardroom that just says this is your for tier 1 what you need to get it done this week, and this feed up to the 6 weeks look ahead that for the higher management, and this feed up to the KPIs or the milestone for the higher management. So we try to keep the feed up approach in place to allow everyone to understand and get online of the project delivery milestones.
Thanks, Omar. So my next question is for Jeroen, that AI is entering infrastructure management, and how can AI help operators move from a more reactive monitoring to more predictive and proactive asset management?
Yeah, so first of all, I think in every country, and maybe even every province and every municipality and every city, you kind of need to create your own, let's say, shared vision on where are we, right? Where are we today? What is our zero measurement? And where is the zero measurement based on? Do we have quality data? But we all agree, yes, this is the situation right now, and how can we then look for change? Because that's the promise of AI. Again, I think it was mentioned in the session before, if you don't have structured data, right, you can totally forget about AI. But it is, let's say, every use case, let's say if I'm doing planning, is completely different than I'm operating, let's say, outside, or I'm doing maintenance, right? So first of all, what is the use case? And what is the data that we trust in our country, in our, maybe province, in our municipality, in our city? And how, because if we have a high-end data set that is updated once in a while, could be yearly, could be quarterly, could be once per 2 years. But okay, this is one data set that we have. Okay, and then on site, we have, let's say, maybe operators will also once in a while update their data, right? And that's data that we trust because it comes from ourselves. But then there's open data, and there's, let's say, a low-end sensors. It could be dash cams or satellites flying over. But what are the data sources we want to work with? I think having the shared vision on, okay, what are the data sets that we trust? How many times does the data sets get updated, and for what use cases can we use them? I think that's crucial. Once you have decided that, then you know, okay, because the AI is always dependent on the incoming data, and the confidence score of an AI model, it really drops down really quickly if the data is not coming in right. It's garbage in, garbage out, everybody knows, but the pain point from AI is that it's always at the end of the process, right? So you're really dependent on the quality of data and understanding, I would say, the end-to-end, from sensor to service, understanding that, but then take the professional and the user as a starting point. It's his or her workflow, that look and feel. And maybe today it's still important that the workflow and the look and feel is good. Maybe tomorrow the AI is doing a lot there as well, right? So you look at the outcome, but that's not today. But then really understanding the end to end and connect the dots there, so that you really know, okay, the professional can rely on this data. And then at some point, you want to have almost automated quality checks on the results. And I think if you can deliver the proof point as well, so I say, I did a measurement, and look, here's the point cloud behind, so I can actually check what was said by the AI model, or even if somebody else did the work manually, that's fine. But if you can make the professionals do the quality checks on not only the data, but also the analytics, they do not even have to spend a lot of time on it, because it can be done automatically as well. But I think given the analytics in the hands of the professionals so they can accelerate, I think that's the next step. And then with agentic coding and agents, there's a lot to come. But really understanding that an AI model, a result of AI, only works if end-to-end everything is under control. And we didn't mention data sovereignty here, but data sovereignty matters big time as well, right? So again, where does the data come from, and where do we actually store the AI, the data and results of the AI analytics, and how do we make sure that we also maintain the local domain knowledge? because if you're not careful about it, then you lose your domain knowledge as well. I say, so connecting those dots, I think that's crucial going forward.
Correct. Thanks, Jero. Myla, I would like to ask this from the point of view of digital twin as well. Digital twin are increasingly being used to simulate and monitor infrastructure systems. How can they help planners design infrastructure that is more adaptive and more resilient?
That is a good question. Thank you for your question. So we see that digital twins have entered this domain recently. It has been used for many other domains, but I would say that in the planning and infrastructure monitoring and so on, that have been kind of used more recently. Before we were using more simulation models or predictive models. We just didn't call them digital twins, let's put it that way. But that they can help tremendously in the fair decision-making process, let's say. When you have this end-to-end this data system, as Jeroen was mentioning, and Omar, when you have all this data system developed in hand, and you can rely in their predictive modeling, let's say having real-time data or let's say frequently updated data that can be maintained in this digital twin system, then the stakeholders, the decision makers can kind of take their decisions a little bit in advance before going and implementing them in reality. So I see this the main benefit, let's say, of digital twin systems, that we can have some simulation, scenario viewing before implementing something in reality. At least this is what we are aiming for. But we should mention something that also links to what Jeroen was saying, that we need to trust the data that is coming in and the simulation output that is coming out. So it's very important how trustworthy are these predictive models that we are developing within these digital twin systems. And this is there is no recipe for this that can be followed everywhere. It's very case dependent and it's very data dependent. So in that sense, for infrastructure modeling, as you were asking me, we should be careful which decisions we can trust and which decisions we can follow based on what our digital twin systems are producing for us. Yeah.
A follow-up question, Myla, to this. You mentioned scenario planning, scenario testing. So how can scenario testing help government and infrastructure operators make better decisions when they are working with so many multiple sets of data and multiple set of stakeholders?
I can give you practical example from our work. For example, we are working a lot in urban planning domain, and when the decision makers have to redevelop new area or start from zero developing new area, they can make scenarios how their new designs can impact the climate and what kind of impact they will have in the future. For example, we have a lot in for example, if you have more green areas or green roofs or solar panels in facades or the roofs of the buildings, or even in the designing of the building infrastructure, how tall should be the building, what should be their orientation, so that we can estimate what the impact of these new developments will be in the environment around. So what we are doing is taking into account energy, heat, wind, transport, water supply, for example, in these new areas. And then, depending on what would be the configuration in your new design of your new area, you can do this scenario planning so that you make, as a decision maker, the best decision in the environment, how to position your infrastructure in a better way so that the impact would be positive for the environment. This is what, for example, digital twin systems can provide you in advance before implementing some solutions.
Well said, Myla. Well said.
Yeah.
So, Jerome, my next question to you is that when so many systems are talking to each other, there is so much of data. How does this collaboration work between the government, operators, and technology providers? What are the key factors for making this type of collaboration work?
I think I'm going to repeat what we said in the beginning, right? I think starting with creating a shared vision. I think that's crucial. And shared vision, because what you see too much, too many times, is that people say, yes, this is one project, and then we're going to be successful. No, this is most of the time the starting point of a longer process, right? So the vision is creating the same shared vision is about the coming 5 years to 10 years. What do we want to achieve, right? That doesn't mean that we cannot achieve things in the first project, on the first, let's say, quarter, but this is technology that's developing really quickly. Okay, we already mentioned data quality, data structure, things like that. But if you have this shared vision, then you also agree on, okay, what are timelines that we can achieve? Because I see so many times where governments, agencies are involved, and we want to have 99% accuracy or 99% quality of whatever, which up front you already know that it's impossible, and still those collaborations start, and tenders are won based on, I think it's well, bullshit is not a nice word, but it's like it's not true, right? So be really honest. Okay, what can we achieve with the current technology, current status, current available data, open data, the experts that we have at hand? What is the challenge that we want to solve? And then really agree on, okay, like we said, the definitions of done, the definitions of success, who is willing to invest in what, and why does it make sense that we collaborate? What is the role of the agency? What is the role of, let's say, the commercial parties? And who is willing to take what risk where? I think defining that really clearly, that's what I miss a lot. It becomes too structured, or let's say it's completely open, but I think that's crucial. We can do way better there.
Correct. Thanks, Jaron. Omar, I would like to ask you that with the rise of IoT sensors, reality capture, so much of real-time data available for us, how can infrastructure manager use this live data to reduce downtime and improve operational efficiencies?
Yeah, so basically, I think, yeah. So basically, you know that when you use sensors, it's for reactive information. So we need to know we need to be to predict what's going to happen here. The IoT sensor can monitor the parameters and could give us more information. I'll try to make it easy to mention in terms of what we do in the IoT sensors. For example, we get the structure movement, the vibration levels of mechanical equipment, for example. We could get also anything electrical system performance. We could, if we bought it in a bridge, we could understand the pattern of that bridge, the movement there. We could detect something wrong happening there proactively. So energy consumptions also. So if you have a specific building and you have the sensor there, you could monitoring also. I'm talking about in the construction, in the construction use, and even in the during a construction use, we could detect that. We could use this also for safety, for construction progress, even information. But at the end of the day, sensor data is integrated in digital twin environment to gain continuous visibility to the asset performance. Okay, so this is, I think, the key here. So as we go, we're trying to plan out the right type of sensors, the right information we need to come out with insights that help us to take actions and to predict things happen. Like, for example, if you have high energy consumption, okay, you need to find a value engineering solution for this space. And we're trying to be more proactive in terms of how we deal with this. For example, for sensors, if we bought, I give an example, sensor in bridge, you could detect abnormal structure movement. If you bought a kind of sensor on the mechanical equipment, you could detect if something wrong happening before you have like explosion or something like that. But we could have this kind of information, and this will end up with us have a smart building, and but if you have a smart, if you building like a bridge, and then you have a school, and you have a factory, you're gonna end up with having a smart city. So you're gonna have more kind of predictable information. You know how data flow. You know what's the issue here, and you could. I would say it this way: when abnormal data or abnormal kind of information happen, you will be ready to deal with in terms of the collecting. You detect early. You try to give a guidance to the maintenance team and try to avoid any failure occur in this. I always I said this many times before in the panel or the conference I have participated with, and Deloitte have a really nice research about this, and they mentioned that if you invest the right planning time for the IoT things like sensors in the buildings and the city, it's gonna end up with approximately 25 to 50% going to cost you less or reduce the unplanned downtime. So at the end of the day, if you reduce the unplanned downtime, you're going to end up with saving money. I'm going to end up with more efficient workflow and more efficient maintenance in action. I think what we just said at the end of the day, we try to shift from being just reactive firefighting. We try to, whenever something happens, we just go and deal with it, to be proactive and to have data, to be backed by data, by data and insights that takes action. So instead of just, let's say, to be a firefighter, we try to treat our project, our project to be more smart, to react better. At the end of the day, we should say that all our infrastructure project treat as a living person, let's say living human. You know how his heart rate look like, how his blood pressure look like. So if something wrong, you could check it earlier, and you could constantly monitor them and learn more, and have the continuous learning and improvement for this facility, and just to avoid any failure happening to it.
Just a follow-up question to this, Omar. As you mentioned that predictive analytics has become very important. So can you shed a little bit of light on how this could help us reduce long-term cost and extend the asset life cycle in some way?
I love this question because, you know, I tell you what happened today. Typically, what happened? We just schedule the traditional way. We schedule time to check things. Okay. If you check it today and something happened tomorrow, because you are not backed by data, you have done what you should do. Yeah, you have done your side. Yeah. So it's not. So again, if we treat the building as a living person or living building instead of just a static building, we will be looking for more like dynamic data and reactive maintenance than the traditional way. And you know, let's start even once the construction project is finished, how the construction team transferred the information to the asset team. They just throw a bomb, and everyone tries to hide it. So you just have a bomb and it's thrown on them. Guy, enjoy, do whatever you have to do. So I feel we start, I think, to have the most kind of like, let's say, the most important thing in the asset life cycle start during the construction, to make it to make sure that you have every asset parameters have been included and done in the right way. I'm assuming this done now, so we're gonna move to the asset cycle. I would say the traditional way, we have a schedule, we have a fixed schedule maintenance based, and I think this is a big mistake. And my point of view, you need to deal with the building in a live building, and also this work, the traditional one, leads to inefficiencies, like components are sometimes replaced too early, or others failed unexpectedly, so you can't control this. But if you have a historic asset performance data, if you have a real-time sensor monitoring, if you have advanced analysis machine, or even a Power BI report that give you information from all the or even a web-based platform that analyze all this data, you will be in much better situation or much better system. You can detect early the equipment degradation or any failure might happen, and just instead of just a static way, you just go and check your data. I might give some example, like an abnormal, again, because I'm civil engineer, I'm referring to bridge. Abnormal vibration happen in a machine or in a bridge. You could detect the pattern whenever it's repetitive. You will detect it if you have a data and historical data. You will understand it, and also the temperature increase in the electrical system. If you have this information have been structured well, and you have this information, you also could track the pattern when this happened. You could know, you might know there is, you can't, let's say when in some situation you can't operate two generators together. You have to be one, because your system won't be allowed to do this. For example, I know there is a lot of catalogs and you might be aware of this information, but once the problem happens, you need to have a pattern to understand what's going on there. So I give example for the temperature increase. I might talk about a change in the structure behavior under load. So this is the, for example, if you have a specific room designed for a specific activity, then by time, because it's a living building, people will change the purpose of this room. And now the kitchen became very close to a generator, and it might happen in some situation that re-innovate the building and reuse the areas. So you might understand there is more changes in the structure behavior under different load, because it wasn't planned to be a conference or a theater for some reason. Now it's being converted to that, so you won't know this information. So this thing, like in very simple word, we talk about abnormal variation, vibration, high temperature in equipment, and we talk about the structure failure. Even if something have been happened, if you have a sensor that give you this information, you'll be a much better place to react and understand why, and give even the right advice who should be engaged at this stage. What I just say, in predictive maintenance, we need to change our mindset from fixed infrastructure after failure and firefighting approach to be thinking more about managing the asset performance continuously in more smart way to get the best result out of it.
Correct. Thanks, Omar. Now, my final question would be to Jeroen, and I think it would be one of the most important questions for our audience. Many organizations are investing in data platform and analytical tools. Now, in your experience, what distinguishes successful implementation from those that fail to deliver the real value? Now, I know you have mentioned that alignment of goal is one of the key important things. Going beyond that, what do you feel organizations should focus on to use this data, use analytics in a more powerful way?
I think listen to the experts, listen to the local domain knowledge that's still today, they're still there. Ask them what software, what platforms they use and why, because it's basically listening to the end user. It's and look, if you have the big tender in US being the biggest market, or one of the biggest markets, right? Filling in one tender to a DOT, still 6 to 8 companies partner together, from let's say from the data until let's say the work that is done. But that tells the whole story. We talk about interoperability, integration, stuff like that. We still need to solve that, right? And make sure that we have the same definitions. Again, because we need to listen to the experts, because AI will not replace a domain expert tomorrow. They will empower them, right? But I think having the local professional empower them, always use them as a starting point. Okay, what data do you need? What insights do you need? How many times do you need it? Why do you need it? But really understanding them, and then make use of all the technology and all the data that's available everywhere. I think that's crucial, because if you want to go from, let's say, a zero measurement towards change detection, towards prediction, towards, let's say, another level where you can really rely on AI, that's still far ahead in a lot of use cases, right? Okay. Far ahead. So with building up and making step by step getting there, I think that's crucial. Like, well, the building example that Oman just mentioned, right? Think broader than the building, right? Okay. Okay, the asset owner of the building, yes, and maintaining that, and okay, but what in the urban environment can be affected by a building, and what data should be used by other, let's say, stakeholders, and why, right? And then, but the same from, okay, there's the fire department, how do we get to that building, which is just on other analytics, but connecting all the information sensors, having a vision on that, and then slowly build up, okay, where do we start? What's the most important if you talk about city safety? What is the most important if you talk about sustainability, data sovereignty, right? That's the highest level, but then immediately go to a professional and build up with the professional, understand, okay, what do you need? And how can we make sure you get it in your workflow? And maybe in the future, agents will help you. And if you do it together, they will not, let's say, hold back on the AI, because the AI will come. But there's a big risk that the AI has too much power at the wrong moments, right? So they should be in control. And I think that we need to develop that step by step. And again, I think it's always local. It's not a let's say, global business case that is solved immediately, because buildings are different everywhere, right? Traffic signs are different everywhere. So it is hyper local, but yet we can use of let's say, global technology that's out there and global knowledge that's there. But we need to work with the local domain expert.
Correct. Thanks, Jerome.
I have just a small question. Could I
Sure.
just ask Jaren a small question? Regarding to I actually like your expertise and the experience you have in AI. So I just curious to ask this question. So in the previous question, we talked about the predictive maintenance. I would like to know if you have any kind of experience with machine learning algorithm to analyze the pattern and analyze the data that we receive and give us kind of insights before even we engage with. Do you have anything you have done something very similar to that?
Yeah, well, not in buildings, but let's say we are working, for example, a lot of traffic safety. And interesting, traffic safety, it has to do with the roads, the traffic signs, the road markings. And of course, there's a lot happening, and there's a lot of data available. There's, let's say, high quality data sets coming from mobile mapping, reality capture, but you also have a lot of low-end sensor data from car fleet data sensors, but the dash cams. Then you have aerial data. So it's a lot of different data sets. But really understanding, okay, what does the autonomous driving, what does the car industry, what kind of data are they interested in? But what is that, say, if in the car itself, and you look at safety, what sensors are used today in the cars? Give you a good example. A Tesla doesn't have a LiDAR, for example, right? But the other cars do. So it's, again, you create together with the ecosystem, okay, vision, okay, what is the idea we can use? What's already automated? How can we make use of data that's already there? Because there is a lot of open data, but again, it's really tricky to make use of the wrong data sets. So what you can do is always rely on a high-end data set. So as a starting point, and if you trust that high-end data set, then with low-end sensors, you look for patterns. You connect them with the high-end data set. I think that's the best example. And then put the professional in the middle, because he or she can judge whatever comes out of AI model or whatever comes out of data or let's say on the analytics. I think, and then you build up slowly, and then you will see that you get more and more AI models that are trustworthy, but also with a high confidence score. But because only with a high confidence score, it really accelerates. It really helps, and it really start thinking from service to sensor. So what do I need, and then look back.
Thanks, Jaron. Thanks, Omar, for this question. I think the answer that we got, it's very useful for us also and for everyone in the audience. With this, I would like to close this session. Thank you, Jaron. Thank you, Omar. And
Thank you, Omar.
I would like to thank Myla as well for being part of this session. I would like to thank the speakers from the previous session as well for joining us and sharing their insights. I would also like to thank everyone in the audience. And if you have enjoyed our conversation and would like to join us, we will be happy to welcome you all at Geospatial World Forum and AEC Summit, scheduled for 20th April to 1st May at Amsterdam. I welcome you all and looking forward to seeing you there. Thank you.